Hello again. So we have reached exercise 11, which is about hashing into some BST. So we have already solved exercise 6, which is similar to this one. So where we have declared the hash table, and we have wrote the functions on how to add an element into such BST and to search element into such hash table. So I will be using the same solution. So I'll start from the solution of exercise 6 in order to solve exercise 11. So for that, in exercise 11, we need to consider a hash table. We're training the elements of type string, so we use a binary search tree. So they are telling us to give the necessary declaration and to write a function that return an array that contains the number of collisions on each cell in the array. This array is named array of collisions. So we have the hash table, which is an array of BSTs, and we need to tell for each cell, for each BST, the number of collisions. So obviously, for example, if I have two elements in the BST, so there is one collision because we have two elements. And for example, if we have just one element, so we have just one collision. So it's like that. So I will start from the same solution of exercise 6. So we have the BST, the declaration of a hash table, to create a hash table, and to insert an element. So we don't need the searching here, so I will remove it, and we will keep the printing of the of the hash table. So I will comment this, and we will move on to the question. So we need to calculate the number of collisions. So we know, so we have the array here, the number of elements equal to m. So I will call the function array collisions. So it will take a hash table, and we need an array because we need to return an array. So let's call it collision. So the size of the array is equal to m because it's equal to the same size of the hash table. So there is no need to pass the size of the array by parameter because it's the same. So we need the int I to loop and another variable x. We'll see why. So we'll loop over the hash table, and we will place in x the number of elements of the BST. So we'll write a function called count for the number of elements. So, and we will place in call of I. So if the x is less than 2, so I will keep x, otherwise I will place x minus 1. So for example, if there's 4 elements, it means that there's 3 collisions. So it's for that. So we need to write the function count, so to count the number of elements into BST. So it's very easy. It's like a B tree. So we'll do it recursively. So if not B, I will return 0. So if I reach null, otherwise I will return 1 plus the number of elements on the left subtree and the number of elements on the right subtree. So this is it for this part. Let's move to the other questions. So in the following we define, so we need to define also the array of intervals of an array AK. So we have AK, and we need to define the array of intervals of the array of integer of length k minus 1, of course, with the following elements. So I will do a1 minus a0, a2 minus a1 till the end. So obviously the number of elements of this array of intervals, it will be of size m minus 1. So let's write the function. So again, it's a void, and let's call it array of intervals. So it will take an array A and the output, which is an interval, array of intervals. So the array A is of size m, and the array of interval is of size m minus 1. So for that, I will loop over the array of A. So I will loop m minus 1 times. So for that, I equal to 0, I less than m minus 1, I plus plus, and I will place an interval of I, ai plus 1 minus ai as requested. And this is it for this part. What we have next, so we need to check if a hash function is almost uniform. So for that, we need to check two things. The first, the difference between the maximum and minimum in the array of collisions, it should be less than equal to 2. So we need to find the maximum and the minimum in an array. And each element in the array of intervals, so the one that we have calculated here, obtained from the array of collisions is equal to -1, 0, or 1. So we need to write a function to check whether a hash table is almost uniform or not. So I repeat, so we have the array of collisions. So from the array of collisions, I need to find the array of intervals. So we've already done that. The next part is I need to find the maximum and minimum of the array of collisions, so the one that we have wrote here. So we need to write a function min-max, and then we need to check that the maximum minus the minimum is greater. If it's greater than 2, it means that it's not a uniform, so it should be less than equal to 0. And then I will loop over the elements here on the array of collisions, which is from 0 to n-1, and we need to check if the elements are between -1, 0, or 1. So if it's outside, if it's less than -1 or greater than 1, it means that it's not uniform and we return 0. So it's not that difficult. So let's start. So we have an array and we need to return the minimum and maximum. So obviously I cannot do it with the return value. I would use pointers. So we have an array. So t, and we know the size of the array, which is m, so there's no need to pass the parameter, the value of the array, the size of the array, and we have a pointer to the minimum and a pointer to the maximum. So of course I will need a loop, and I will initialize min and max to t of 0, and I will loop from I equal to 1, I less than m, I plus plus, and I will check. So if t of I is less than the reference min, so now the reference min would be equal to t of I, otherwise else if t of I is greater than the reference max, so I will update the max, which is t of I. So this is it for the minimum and maximum, and then we need to write the function, which is the almost uniform. So almost uniform, so it will take just a hash table. So from the hash table h, let's call it h or t, capital T. So we need to find the array of collisions. So I just need to call this function. So array of collisions. So it will take a hash table, and I need an array of collisions. So it's an integer. So let's call it int col. So the size of the collision is equal to m. So after calling the collisions, I need to find the array of intervals. So an array of intervals, it takes an array of collisions. So here we give them a t, and it needs an array of intervals. So the array of intervals is of size m-1. So I will copy this and declare an array of size m-1. So after doing that, I need to find the minimum and maximum of the array of collisions. So I need here int min and max. So t is the array of collision, so it's t, and then here we have address to the min and then address to the max. So let's come back to the question. So they are telling us that in order to be uniform, the difference between the maximum and minimum in the array of collision should be less than equal to 0. So I will check. So if max minus min is greater than 2, it means that it's not uniform, so I will return 0 directly. And they are telling us that each element of the array of intervals, it should be in between -1, 0, or 1. So here I will need also a counter I. So I will loop over the array of intervals. So I equal to 0, I less than m-1, because it contains m-1 element, and I will check. So if the interval here, the array of interval of I, is less than -1, or if it's greater than 1, it means that if it's outside -1, 0, or 1, I will return directly 0. If everything goes well at the end, I will return 1. So, and this is it for the question. So I will check if this function of this hash table is uniform. So it's uniform because the difference between each of the elements here is at most 2. So if you can see, and the minimum and maximum, so it's not greater than 2. So let me just update this. So let's say here almost uniform, and I will call the function almost uniform on the hash table, our hash table h. So let's execute and see the output here. So we have a problem here. So let's see the min max. It's called min max t array of intervals. We have a t. So it's not t. The array of intervals is called t. Here we have collisions, number of collisions. So let's execute. So yes, it's almost uniform. So this is it for this exercise. So let me skim quickly over it. So we needed to row the array collisions, so the number of collisions in the hash table. So we took the hash table and we returned an array of collisions. So we just looped over each BST and we have counted the element into this BST. So if the number of elements is less than 2, it means equal to 1. I will return minus 1. And if it's for example is greater than 1, for example 2 or 3, I will do the number of elements minus 1. So and then we were asked to write a function to calculate the array of intervals. So it's the difference between two consecutive cells, and then we wrote the maximum and minimum function on an array, and then we have just called the previous functions in order to check whether the hash table is uniform or not. So this is it for this exercise. If you have any questions, do not hesitate to write to me and I will answer you back, of course. And again, thanks for watching.